Now that we're talking about accelerated motion, the idea of average velocity and instantaneous velocities will be a little bit clearer. We've been talking about average velocity, so we started with the displacement over time, the delta x over delta t formula. That formula is still valid if we know the displacement of an accelerating object and we know the time that it took to make that displacement, then we can find the average velocity. When we're talking about accelerated objects, though, two things that are important are these instantaneous values. So we have instantaneous velocities here. Instantaneous simply means what is my value at some instant of time. So average velocity we took over a time interval. An instantaneous quantity or instantaneous velocity would be what is my velocity at this instant of time. So for example, the initial velocity would be the velocity at the initial point when t is equal to 0. Okay, my final velocity would be what is my velocity at some ending time, say 5 seconds. So what is my velocity at 5 seconds? Okay, so we can take a look at this little diagram here. So let's just say that we have a ball rolling down a ramp. Okay, the ramp is providing acceleration. We know that if we tilt the ramp up, the ball is going to speed up as it goes down the hill. So I start the ball here at this position. The VI, initial velocity, would be 0 at time equals 0. I let go, I release the ball, it rolls down the ramp. It covers, this ramp is some delta x. And when it gets to the end of the ramp, at the bottom, let's say the final velocity is just 7 meters per second. I made this number up. It's 7 meters per second at 5 seconds. So let's say the ball has been rolling for 5 seconds, and the final velocity would be 7 meters per second. So we know the average velocity. We can use this formula if we know the delta x, which we can measure, and we know the delta t, which we can clock. You can clock that with a stopwatch. We could find the average velocity. Okay. If we did not know these two things, we can find the average velocity another way, right? And we would need to know the average velocity relative to these quantities. Again, because we're talking about accelerated motion, we have some initial velocity and some final velocity. Okay, so let's take a look at that. And again, we're trying to establish a relationship between the average velocity, average velocity, and the instantaneous quantities, VI and VF. Okay. All right. So we're going to do just a thought experiment here. We're going to pretend that we have the ball rolling down the ramp. The ramp is providing a uniform acceleration, meaning a constant acceleration, of 2 meters per second. So every second, my velocity is changing by 2 meters per second. It's increasing. We initially release the ball from the top of the ramp with an initial velocity of 0 meters per second. Okay. All right, so we want to calculate final velocity values. Right? So at 0 seconds, again, the initial velocity is 0 meters per second. So after 1 second, well, because my acceleration is 2 meters per second, after 1 second, my final velocity would be 2 meters per second. Okay. After 2 seconds, well, if I've gained 2 meters per second, after 2 seconds, the final velocity would be 4 meters per second. Okay. After 3 seconds, I've gained 2 more meters per second. So this would be 6 meters per second. So on and so forth. 4 seconds, I'm going to gain 2 more meters per second. So this would be a value of 8 meters per second. I didn't have to write the meters per second. Okay, so we get the idea. Every second, my velocity is increasing by the acceleration rate, which is 2 meters per second every second, right? So we want to find the average value of these numbers. So I'm just going to say we have 2, 4, 6, 8, and of course we have 0. Okay? So, how do we find the average of these numbers? We can do that. We can add them up and divide by the number, right? So in this case, we've got 1, 2, 3, 4, 5. Let's just sum this all up. It's going to be 6, 12, 20. So the average velocity here would be, again, do 6, 12, 20 meters per second divided by, I've got 1, 2, 3, 4, 5. So this would be 4 meters per second. All right. Now there's another way that we can find the average value. Again, we're trying to pull in this VI and the VF. So we can recognize, guys, this is an arithmetic series. If you think back from a math class where if we have an arithmetic series, we can find the average of the series by finding the average of the first and last term. So the V average in this case would be the initial velocity would be 0 meters per second plus the 8 meters per second and divide that by 2. Okay, that is the average of two numbers. I simply add them and divide by 2 and we get 8 meters per second divided by 2 equals 4 meters per second. Okay, so why do we want to do this? Because now symbolically, instead of using the values, well, this is my VI, right? That's VI, and 8 meters per second, since that is my last velocity, that's my final velocity. So I can rewrite this as VI plus VF over 2. Okay, so this would be the average velocity equation that we have in accelerated motion, right? And we can solve this. Again, you can manipulate this however you choose. If VI is 0, then I just have VF equals twice the V average velocity. Okay. All right. So this is our equation. When we're talking about accelerated objects or accelerated motion, we have a value for the average velocity in terms of the initial velocity and the final velocity. Okay, these are the instantaneous values, initial and final. When VI is equal to 0, my final velocity is simply twice the average velocity. Okay, so this is important, and we'll use this going forward.